In this video, I am going to explain symbol table organization for block structured languages and non-block structured languages. First of all, what is symbol table? Symbol table is a data structure that is used by the compiler to store information about identifiers and many other program constructs while the program is being compiled. There are two basic operations that are performed on the symbol table, namely insert and lookup. Insert is an operation used to add new entries into the symbol table. Lookup is an operation used to search an existing entry in the symbol table. Symbol table management is required for following reasons. For the quick insertion of identifier and the related information. So you have to manage the symbol table properly so that the insertion of a symbol into the table is done very quickly. And quick search of identifier is also possible. So the symbol table should be organized or managed in such a way that it supports insertion and search operations efficiently, quickly, as fast as possible. The performance of the symbol table depends on how the elements are arranged and organized in the symbol table. The type of symbol table organization technique applied in the compiler design depends on whether the language is block structured language or non-block structured language. First we will see non-block structured language. A programming language that does not support the creation of blocks, within a program is called as non-block structured language. That means in non-block structured languages there is no blocks creation and local variables declaration. Variables are always declared openly and used by all statements of the program. Some older languages like Fortran assembly language does not support blocks definition. In this program, statements are written sequentially one after another. Commonly used data structures for symbol table organization in non-block structured languages are ordered symbol table and unordered symbol table. Next, block structured languages. What is block structured language? A programming language that permits the creation of blocks within a program is known as block structured language. It is a higher class of language in which a program is made up of blocks, where a block may include nested blocks as components such that the nesting depth can be. Usually a block consists of sequence of statements preceded by declaration of variable. Suppose function is a block of statements with some name. When that block name is called, its body will be executed. For example, C++ and Java languages divides the program statements into blocks like loops, functions, etc., delimited by flower braces, opening brace and closing brace. The commonly used data structures for symbol table organization in block structured languages are listed below. List data structure, linked list data structure, binary search tree, hash table. Next topic. Symbol table organization for non-block structured language. So what is non-block structured language? We should know first. A programming language that does not permit the creation of blocks within a program is called non-block structured language. That means no blocks creation, no local variables creation. Variables are declared openly and used by any statements in the program. Example languages include Fortran and assembly language programming. So commonly used data structures will be ordered table and unordered symbol table. First we will see ordered symbol table. In ordered symbol table, the entries of identifiers are made in alphabetical order, some sorting order. The searching of an entry in the table is done using linear search or binary search. So in this table, the elements are in sorting order. So you can use binary search to search an element from the list of symbols found in the symbol table. So advantages will be the searching of an identifier is efficient. The relationship of a particular variable with another can be easily established. We can find out easily what are the variables whose name starts with A, suppose. Like that we can do some sort of searchings easily. Drawbacks are, if there are number of entries in the symbol table, then insertion of an element in ordered symbol table is costly. That means before inserting any item into the table, we should find the proper location where it is going to be inserted, so that the total list of symbols in the table after insertion is in sorted order as earlier. Unordered symbol table means the elements in the symbol table are not ordered in any format. So in this type of table, variable entries are not made in sorted manner. That means as the variable is encountered, then the entry is made in the table as next available location in the sequence. So no order for creation. We can insert a symbol into the table in the next available free slot, whatever it is, in the next available slot in the symbol table. And each time before insert to check whether it is already present in the symbol table or not. If present, duplicate names are not allowed. It will be error. Advantages: insertion is easier. We can insert the element easily in the next immediate free slot available in the table. Drawbacks: because elements are not in sorting order, searching is done using linear search only, so it is inefficient. And for larger tables, the method turns to be inefficient because lookup is made before every insertion. Next, how names are stored in the symbol table. So while discussing ordered symbol table and unordered symbol table, we have to discuss this point also. There are two ways to store names in the symbol table: fixed length name and a variable length name. A fixed size space is allocated for every symbol in the table in this method. For example, I will take the variable name calculate sum A and B, suppose. So here it is the variable name, symbol table, name is going to be stored, and attributes, corresponding attributes, size or address or what is the initial value. Like this, the attributes will be maintained according to the information of each identifier. So here the name size is fixed. So for example, the calculate occupies 9 characters, so its size, for the sake, 9 bytes. Similarly, For the next variable also 9 bytes. For the next variable also 9 bytes, and so on. But here when you observe the second variable sum, its size is not 9. The name of this symbol, name of this variable occupies only 3 characters, so remaining all going to be wasted. Similarly for a variable also, it occupies only 1 byte, remaining all going to be wasted. That means in this type of storage, if name of the variable is small, then there is a wastage of space, and the name can be referenced by the pointer to the symbol table entry. Next, variable length names. The amount of storage required for storing the name is calculated and is used to store the names. So in this method, the memory space required to store a name is not fixed, it depends on the identifier name length. So the name can be stored within the table using starting index and length of the each name as shown below. So for example, I'll take the same 4 identifiers, calculate sum A and B. Here calculate occupies 9 bytes exactly. So here the starting index of the array is 0. It occupies 9 actually, 9, but here we are storing 10. The reason is it also contains the end of the string, end of the name character also. See here. So the calculate name is going to be stored in the symbol table from 0 to 9 indexes of the array. Actually it occupies only 9 characters or 9 bytes, but the last one or one extra byte, one extra character is going to be assigned for each name, for each variable name, for each symbol name in the table to represent its end of the name. So it occupies 10 bytes, so its length is 10. Its length is 10. Similarly, the next name is sum. It occupies actually 3 bytes, but here we will represent as 4. The reason is one is for storing end of the name. So its index starts from 10 and ends at 13. So next variable is A. Its index starts from 14 and length is 2. Similarly, next variable is B. So its size is 2 bytes or 2. Index starts from 16. So in this way, we are going to store the names using variable length name format in the symbol table so that we can save the space. It's a efficient method of storing names in the symbol table. Next topic, symbol table organization for block structured languages. So earlier we have seen non-block structured, now we will see block structured languages. A programming language that permits the creation of blocks within a program is called block structured language. So block structured language allows the creation of blocks, where block is a collection of statements, and each block may have declaration of variables also. For example, C, C++, Java, all language supports the creation of blocks like functions, etc. using delimiters, opening parenthesis and closing parenthesis. The commonly used data structures for organizing block structured languages is listed below. List data structure, linked list data structure, binary search tree and hash table. Let us see the first one. List data structure means array. In the array, we are going to store all the information regarding the identifier. The information may include its name, field, its size, information, default value, scope information, or some other block level, whatever it may be. So linear list is the simplest kind of mechanism to implement symbol table. In this method, array is going to be used to store the names and associated information of an identifier. New names can be added in the order they arrive. So whenever new name encounters in the source code, it is going to be stored in the symbol table in the next available free space. No sorting order maintained. So how to find the free space in the array means using the pointer available. The pointer available is maintained at the end of all stored records to indicate the empty slots. The symbol table maintained by list data structure. This is the name of the symbol, and these are the attributes of the name. Here just we are saying information, but it may have many fields also. Value, the size of the name, and other things. So name 1 and corresponding information is stored, and name 2 and corresponding information is going to be stored. Similarly, name n and corresponding information is going to be stored in the symbol table sequentially. Here how to find free space means by a pointer called available. So the available pointer points to the start of the empty slot in this array. So this format is called list data structure. To retrieve information, retrieve means access the information about some name, we start from the beginning of the array and go on search up to the available pointer. So here the elements are not in sorted order, so we cannot perform the search using binary search. We should go through the linear search. We should go through linearly one by one. If we reach the available pointer without finding the name, then we say that the identifier not found. Otherwise we say found. Advantage. The main advantage is it takes less amount of space. Simply we are storing the variable name or identifier name and corresponding information into the symbol table without any proper order maintenance. Simply one by one will be stored. So it occupies less amount of space. Drawback. The searching an identifier is very difficult. We have to perform linearly only. Second data structure is linked list data structure. This symbol table representation uses linked list. You know linked list. Linked list is a collection of nodes in which each node contains data field as well as link field. So in each node a link field is maintained, is added to the record so that we can find the next element, next node in the list. We search the records in the order pointed by the link field only. And to represent starting of the linked list, a pointer first is maintained. So list is the collection of nodes where each node represents identifier, name and corresponding attributes. We call that one as a record. So a pointer first is maintained to point to the first record of the symbol table. We search the records in the order pointed by linked fields only. So I want to search a record. Here the records are not stored in the sorted fashion. So we have to search the elements or identifiers one by one by a linear fashion, but we have to use the link fields. The format is shown below. So here the first represents head of the linked list, head node. So this is the starting node, name 3 and information 3, and from this there is a link to name 1 name 1, and from this name 1 there is a link to name 4. From name 4 to there is a link to name 2 node, and so on. So like this, some links are there from one node to another node. To search a node or to search an identifier, you have to go through the links only, or accessed or created, then it is moved to the front of the list as a part of this data structure implementation. The reason is the most frequently referred names will be tend to be accessed more often and to be front of the list. Hence, access time to most frequently referred names will be the least. Advantage: linked list organization takes less space. Insertion is easier, but searching is requiring all the nodes traversing from starting to the particular node that we are finding search. Third one, binary search trees. Implementation of symbol table. The symbol table is represented as a binary search tree format where the node structure contains 4 fields: left child, right child, symbol name, and information. The left child stores address of the previous symbol, and right child stores the address of the next symbol. The symbol name field is used to store the name of the symbol, and information field is used to store all the attributes of the symbol. So here binary tree structure is basically a binary search tree in which the left side node is always less than and the right side node is always more than the parent node. So this such condition is satisfied in the elements of the binary search tree. Hence, insertion of a symbol is efficient and searching process is also efficient. For example, take this piece of C language code and try to create tree structure representation for the symbol table. So here first find the identifiers found: K, M, N, next one A, B, C. These are identifiers, and compute is also identifier, P is identifier, P is identifier, next T is identifier. So for this we are going to represent a binary search tree. So what is the starting node? K. K will become the root node. Next node is M. Next symbol is M. So accordingly the search condition, the nodes will be arranged in the binary search tree. See here, the root node is K and corresponding information. This is the symbol name. The corresponding information here, a type is represented. It may have another fields also. For the sake of simplification, we are representing only one information about this identifier K. So K is integer, integer is information. Next I have to store M actually. So M is something higher than K, or which comes later than K, so it should be right child of K. Next I have to store N. Next field, next identifier is N. N will also be right child of M symbol. Next try to find the next symbol. Here is A. So A will be left child of K node, left child of K node. And next one is B. B is right child of A, and C is also right child of compute. Is also an identifier because function name is also identifier which has an entry in the symbol table. So the compute is going to be stored as right child of C symbol. Next one is T. Another variable is P. So P is going to be stored as right child of N. and the last symbol is T, so T is going to be stored as right child of P. So in this way binary tree structure is maintained, so that the symbols information, identifies information including its attributes are maintained detailedly in a tree structure, so that we can insert a symbol information into the tree and access particular node easily. Next, hash table representation. In hashing scheme, two tables are maintained. One is hash table, second one is symbol table. The hash table consists of k entries starting from 0 to k minus 1. It's just something like index. These entries are basically pointers to the symbol table, pointing to the names in the symbol table. To determine where the name is going to be stored in the symbol table, we use a hash function, h of name, that gives the any integer between 0 to k minus 1 that points the specific location in the hash table. So we can search any name using the hash function as shown below. Position is equal to h of name. H is the hash function, name is the identifier that we want to search. That gives the position exactly where in the table this symbol can be found. For example, take the code given below and try to create hash table implementation of symbol table. So here also same number of identifiers are there, k, m, n, a, b, c, and compute, thereafter p, and then t. So for this the table is going to be created as shown below. So here two tables exist, one is a hash table and one is symbol table. Symbol table is a linked list of nodes, suppose. So hash table is used as a index, array of index values. So here first pointer is a, second one is b, third c, d, and so on. So alphabetically pointers are maintained or indexes are maintained, and accordingly the entries will be stored. See the first symbol in the code. The first symbol is k. So I have to find the hash function of k. Suppose here it gives k because alphabetical order. So k will be added as a node in the linked list whose index is pointed by k in this hash table. This is the adding process. Next one is m. So a symbol m is going to be added at index m. At index m. So here it is node data field is m, or symbol name is m, and it has some other attributes, maybe a type or a size or address or some other information. Next variable is n, so that will be stored at index n. Next variable is a, so a is going to be stored at index a. So next symbol is compute, actually compute. So when I apply hash function, it gives suppose c, so I should store this name whose index is c. So accordingly this should be added to c list, but here already one element is there, one symbol c is there, so I have to join the compute symbol as a node next to the c by this link form. And next one is p, so p is going to be stored at index p, and last one is t, t is going to be stored in the table at index t. So like this we have to maintain the hash table. Here the main advantage of hashing is searching is efficient. Insertion also easiest task, but the drawback is it requires more space to implement. So I have to maintain the information about hash values as well as symbols. So when you require 2 table space instead of 1 table space. And one important point is the hash function should be selected in such a way that there is a uniform distribution of names in symbol table, so that there will be minimum number of collisions. So it is about hash table implementation. So in this video I have explained you symbol table organizations for non-block structured languages and block structured languages. With this, unit 4 is completed. Thank you.